in this video, it's going to be different compared to my previous ones. Today we're going back to the classics. What I mean by that is my very first video, which is basically about the laws of exponents. Uh, I'll be doing a bond paper lecture. It's not going to be long. I just wanted to show you some of my works when I was reviewing for the physics examination, in third quarter physics examination. In a year, we have 4 quarters, and each quarter has exams. So there are 4 quarters in total, and this was for my third quarter physics, grade 12. So this is the last year for um, primary, no, not really primary, secondary schooling in the Philippines. So what you're seeing right now is all of the, perhaps maybe not all, but at least most of them, most of the values involved in this exam. So we have force, tension, weight, distance or height, torque, work, power, energy, impulse, and momentum. So I mentioned in the previous video, my video on impulse and momentum, that I might work on the collision video, but I don't think I can. Our teacher didn't teach that, so just to be safe, I would not try to teach something that I was not taught. So as simple as that. So force is, the unit is in Newton. So N, which can also be written as kilograms times meters per second squared. I've always stated this in the previous videos. So Newton is always going to be kilograms times meters per second. For tension, it's also in newtons. Yeah. For weight, wait, something's wrong here. This is supposed to be mass, not weight. Yeah, I have to correct that. Okay, so this is supposed to be mass. Now we have distance or height, that's in meters. Torque is in Newton meters. I've also stated this in the previous videos. For work, it's joules, although essentially joules and Newton meters, they're the same. So yeah, as I said here, one Newton meter is equal to 1 joule. And the Newton meter is also written as this. So power is in watts, which is basically joules per second. Energy is also in joules, the same as work. Potential kinetic energy, total mechanical energy. So they all have the unit joules. For impulse, we have Newton seconds or Newton second. For momentum, kilogram times meter per second. So for the impulse and momentum theorem, we have, it's basically says that impulse is equal to momentum. So yes, work energy theorem, network is equal to the change in kinetic energy. Yes, that's going to be I believe that's going to be important in this kind of worksheet. I know it's kind of overwhelming, but this is somehow similar to my video on potential in kinetic energy. I believe that was number 4. We answered a question similar to this. We had to fill up, we have to solve for KE, PE, TME, power, and power. Well, not TME. We had to look for time. So yes, yeah. So essentially, the work energy theorem states that the values in KE, they're equal to work. So yes, provided that you have found KE, you have to look for work. It's the same value, so just copy. So yes, that's it. Back to where we are. Momentum, P is equal to mv. Impulse, J is equal to force times time. Okay. In other topics involving force perpendicular and force parallel, I believe these are going to be important. This is pre-calculus, but it's also used in physics. So sine 90 is equal to 1. Cos 0 theta is, so cos 0 degrees is equal to 1. Sine 0 is also 0. So, wait, no. It's not related to this. I believe it's related to torque. So, I also mentioned this. Counterclockwise is positive, clockwise is negative. T net, or the net torque, is 0 Newton meters if the object rotates at a constant angular velocity. In other words, the angular acceleration is equal to 0. This is just a random triangle. I think this corresponds to the last question in that video. Although yes, I mentioned there that you can solve the same question two ways. This is one of them, using degree values. But it's not needed. You could still find the answer to that question even without using the angles, involving the angles. So, net torque is equal to TCC minus TC, and if we have a ruler, we have F1 and F2. For torque, it's equal to Fd. If it's not a ruler, then the formula for torque is Fd sine theta. And so, yeah, if you want to extend the formula for net torque, it's Fd sine theta of everything here is under counterclockwise, and here everything is under clockwise. So, yeah, if M and D are given, then this is the formula for net torque. So mgd, basically mgd of counterclockwise minus mgd of clockwise, such that the only same value here is the gravity, the gravitational acceleration, which on Earth is said to be 9.8 meters per second squared. So yes, useless force, this is always going to be the force that intends to go towards the pivot or the fulcrum itself. So yes, it's considered useless since it's not going to change anything in how the lever could possibly move, or the ruler could possibly move. So at the back page, these are formulas. In our school, we consider it for worksheet 3.1, 3.2, and 3.3. These are basically forces, push, pull, and tension. So yeah, basically these are all the formulas. And at the other side, about inclined planes, these are the formulas. So this is where we have the force perpendicular and force parallel. And this is the general illustration for an inclined plane problem. So we have the object, usually it's at the middle, but if it's specifically stated that the object is at the top, then you put it at the top. If it's at the bottom, then you put it at the bottom. But usually, if the scenario states that the object is moving, so we have vi, initial velocity, which is somewhere here, and VF somewhere at the bottom. But usually the object is just said to be stable. So Fn, Fa going down, Ff over there, weight going down, force perpendicular that way, and then force parallel equal to Fa, since they're parallel to each other. So yeah, that's what I just said. It's mentioned here. So of course, we have the formulas for the summation of forces with respect to the x and y axis, as well as the frictional coefficient and the kinematic formulas. Granted that, based on what I stated earlier, there are scenarios where the object is moving, so these will come in handy. And yeah, these formulas are on the topic of tension. They fall under the topic of tension. These are no longer about inclined planes. So yeah, I think that's it. Should I still discuss other reviewers? Maybe. Although yes, I've already made videos answering these questions using my iPad, like using Notability, the note-taking application. Although yeah, when I was reviewing, I answered them using bond paper. So yeah, starting with the very first worksheet. There's still a lot more in this. Although yes, I'll say it again. Those videos already described how to solve the questions. So yeah, I believe that's it. I don't really have anything else to show. I'm not gonna throw these papers away. They're important, very important. This is for torque, by the way. I also answered this. I mean, I also have a video on this. Yeah, I suppose that's it. This one was my answer key when I was making the videos on work and energy, potential and kinetic energy, as well as momentum and impulse. So yeah, thanks for watching.